Yes.
Okay, good. All right, I'm going to go straight to 2.6. And one way I suggested in my webinars on how to go about solving these type of questions, I usually take a snapshot. I have this snapping tool. I take a snapshot, and I recommend all students to start doing that. Either you can use a snapping tool. Microsoft Office comes with something similar. So once I copy the exercise, I just go to Excel, and I just put it right here next in front of me. That way I know how to work through the exercise without flipping back and forth, right? I find that to be good practice. So once I have the exercise here, I have some input data. And then the first thing I do is I start building my model in this fashion. I have some input data. This comes from the exercise. And then I have decision variables, and then objective function, and then constraints. And don't worry, I have this recorded, so I'll be sending you the recording afterwards. Just make sure if you have questions, write them down. Focus on the exercise, not focusing on the other things like note-taking, whatever, because that's going to be provided to you afterwards. So what we're saying in this exercise, let me magnify it a little bit, is this company has blend 4 components of beans in order to make 3 blends of coffee, okay? One is sold to luxury hotels, another to restaurants, and the third to supermarkets. So we have 3 blends that we're making for the luxury hotels, for restaurants, and for the supermarkets. The company has 4 reliable bean supplies that supply these 4 components or beans. And we have one from Argentine Bando, and we have this one, we have Brazilian, and we have Chilean Saburo. The table below summarizes the very precise recipes for the final coffee blend. So we know this blend, Hotel, it takes 20% of this bean, 40% of this bean, 15% of Maximo, and 25% of Saburo in order to make the hotel blend. For the restaurant blend, it takes a different recipe. And so it's for the market. Okay? All right, so this is like a mixture. When we see a mixture, we know there's a blending model. You're blending a few things together in order to come up with the component, with the assembly or the final product, or in this case the blend, right? So we're blending these 4 items, or mixing these 4 items at these percentages. Okay? And what we know is the cost per pound for these components or beans is this: 0.60 or 60 cents for Adendo for each pound, so on and so forth. And we have the maximum weekly availability. This is what the suppliers can supply at a weekly basis. They can't supply more than 40,000 pounds of this bean, and so on and so forth. Okay? What we also know is the wholesale price per pound. This is what we're selling price per pound of these blends are listed below. Okay? So this is the cost for the raw material. This is the selling price for the product that we're selling to the wholesalers or market. So with that being said, let me finish reading through this. The table below summarizes very precise recipes for the final coffee blend, cost and availability information for the full components, and the wholesale price per pound of the final blends. The percentages indicate the fraction of each component to be used in each one. Okay, so the processor's plant can handle no more than 100,000 pounds per week. So we know the plant that takes all these components and make them into these blends, this is their capacity. So we know the supplier's capacity, but we know also the processor plant, what's their capacity is 100,000 pounds per week. And Hilo Beans would like to operate at capacity. No more. They want to operate at capacity, so if possible, which means that less than or equal. So if they can operate at 100,000, that's great. But if they can't, that's okay. At least they have to be closer to that. Selling the final blends is not a problem, although the marketing department requires minimum production levels. So what we're saying here is we're talking about blends, and marketing department requires a minimum production levels of 10,000, 25,000, respectively, for the hotel, restaurant, and market blends. See, this is when it gets interesting. That, okay, now I need to figure out what we're working on. To maximize weekly profit, how many pounds of each component should be purchased? Okay? So we know here the objective function is profit. Okay?
Okay.
And the other thing is, what we're trying to find in this exercise is how many pounds of each component should be purchased to maximize weekly profit. The only tricky thing about this exercise, and I try to make sure that everybody, for everybody to understand how to work their way through it, is that I give some ideas here. And if you look at the announcement page, I already clarified that for this exercise, you need to have 3 decision variables, and those are the 3 different blends: hotel, restaurant, market. Once you see this, you don't even have to spend too long thinking about it. Just, you know, you have 3 decision variables. So what I would suggest is maybe highlight them in a certain color. And I already mentioned those to you: hotel, restaurant, and we have the next one, which is market. Okay. Thank you, Professor. All right. And now we're ready to start working on the rest of it.
Okay.
So let's work through the constraints first, and then we'll get back to the objective function. Okay? And the constraints are stuff that's been already given to you. Let me do something here very quick. So if I click here, that will give me a set of information. Okay. This is the information that came with the exercise. What I'm going to do is I'm going to take this exact same information that you see here. I'm going to copy it, just this portion here, and I'm going to dump it right here under the constraints. The reason why, because first you want the array, the size of the constraints to match the size of the decision variables for these exercises. So obviously it does look like we're all matching the size. We have 3 here, we have 3 in this section. This 10% corresponds to the market. See that? Same thing here, same thing here, and everything else corresponds to that. Now, And then the next thing you do is you write left-hand side, which will be a formula all the times. And here is the symbol. Is it greater than, lower than, or equal? And then we have the right-hand side, which are the constraints. And what we know here is this is where we need to be at a maximum weekly availability. So that goes directly here. Okay?
Mm-hmm.
40,000 for addendum, 25,000 for this, and so on and so forth. And we know since it says maximum, we just say less than or equal. So we'll drag this down. If I'm going too fast, please stop me.
Okay.
Yeah. And next, I'm not going to even worry about this formula for now. Let's finish up the rest of them until we feel comfortable. So what is the next thing on this list that needs to go under the constraint section?
The marketing department requirements, the minimum.
What was the marketing department requirement?
That there is a minimum production levels of 10,000 for the hotel, 25 for restaurant, and 30 for.
So let's write those down here. Restaurants and market. And we know, first thing I do is just write down what they already gave you, 10,000, 25,000. These are your constraints provided through the exercise. And those go directly here in the right-hand side. This is what we mean by the constraint. Okay. All right, and what we want to do is requires a minimum production level, which means you have to be less than or equal or greater than or equal or what?
Greater than or equal?
That's correct. So a minimum of means that greater than or equal. So how are we going to write this?
I don't know.
Okay. So when you try to write the demand requirements for each of these items, such as this example here, what we do is there is a formula called some product formula that we've been using in both Module 2, Module 3, and 4. The webinars definitely explain that very, very well. And if you look at the sum products formula, what it does is if you try to do, if you write something like this, sum products, and take this array multiplied by this array. What it means is instead of writing the formula like this here times whatever solver comes up with, the quantity, plus whatever we set under the hotel section, times, or restaurant section, times whatever the quantity for restaurants, plus this here, times whatever the quantity comes up for the market. Instead of writing the formula in this fashion, where you have to multiply a value by another value and then add it to a value, times another value, add it to a value, times another value. The easy way you could do this is just do sum products function. See, and Excel explains that also in their help section. You could read quite a bit about this, and it tells you exactly how it works. But what it does is basically takes whatever is listed here, multiplied by whatever is listed there, exactly in the fashion that we explained it. So, with that being said, in order to cancel out the restaurant and the market, because all you're worried about is hotel, what are you going to write down here? You want to cancel out, because you're going to multiply this by whatever number here, but you want that to be canceled out, and you want that to be canceled out. What are you going to use as a value that cancels another value out?
0.
0, yes. And you're going to cancel market, right?
Mm-hmm.
And we put 0. So let me change this instead of percentages. Let me just change them to numbers. Let me format this section. Say number. Okay. All right. So for this one, what am I going to write under or next to hotel?
Is,
It will be a 1.
oh,
right?
okay.
So whatever solver comes up with
Mm-hmm.
times 1, it will be whatever that quantity,
Okay.
right? And that quantity has to be, see, that's what's going to show up here. And
Okay.
that's going to be greater than or equal to 10,000. When I do restaurants, I'll do, what am I going to write in the restaurant?
1.
So where do I write?
Oh, for 0. 0.
So this one's 0.
And that would be 1?
1, and this one will be a 0, right?
Mm-hmm.
How am I going to write market?
0.
0, 0, and 1. There is another constraint that's mentioned here, which is the processor's plants can handle no more than 100,000 pounds per week. So how do we write that down? So this is processor's plant max production, right? And the way we can write this down, could you give it a try?
I just got signed out. Hold on 1 second. It just, the meeting, the computer went, I'm reconnecting. Okay.
If you give this one a try, the processor's plant maximum per week is 100,000. So we're saying that their maximum is 100,000. Do we have to be at a greater than or less than or equal?
Less than or equal to?
Good. And when we talk about how we're going to write this down, what should we have in this section? It's also going to use zeros and ones. Or maybe just as zeros, or maybe just ones. So
just ones?
What? Sorry?
Is it just ones?
Yes, exactly. That's exactly right. So it's going to be whatever solver comes up with for all these lands, that total has to be less than or equal to 100,000. That is the way we write this down, using some product formula. So now we are ready to write everything using some product. And the way we do this is we just take this array, multiply by the decision variables array. And for the best practice, use the F4 to make that an absolute array. So we'll do enter, and then now we can drag this down. That F4 saves us because it always looks at this section, but it picks up the next line, as you could see here. Okay, so this is truly what's required to set up the constraint section. Any questions here?
No, that was like the second part of the constraints was where I was really getting stuck. So that answered the majority of my questions.
Okay. And you know how to set up the profit section and everything, right?
Yes, I think so. I have to look at it. I can't like think of it off the top of my head. I'd have to like look at my the other profit functions.
Okay.
Oh, is it the wholesale?
Yeah.
Okay.
So when you're talking about finding out the profit, you have cost and you have wholesale price. You already have these values, 1.25, 1.5, 1.4. Right?
Mm-hmm.
And then to figure out cost, what would that be?
Is it the cost per pound that they give us?
Sorry?
The cost? Is it the cost per pound?
That is correct. But this is the pound for these components, not for their blend.
Okay.
See that?
Mm-hmm.
This is 60 cents cost for the abandon. But for the hotel, we have to figure out what's the cost to make that. But we have percentages. We have some costs here. So what we can do is multiply these percentages by these costs to figure out the cost per blend. So for example, the first one, it would be 0.6 times, 0.2, and that would be plus 0.8 times 0.4 plus 0.55 times 0.15. And you can use some products in this case. Once you have the data available up here, you could use some products instead of doing it in this fashion. 0.7 times 0.25. See, and this is how we came up to the cost. Your profit will be the selling price minus cost, and this is for hotel. And you do the same thing for restaurant, you do the same thing for market. And then for your objective function, this is where your objective function is going to go. It will be the sum product of your profit multiplied by your decision variables. And this is your total profit. Does that make sense?
Mm-hmm.
So once you're at this point, the rest is pretty much simple. You go to the solver. You tell solver, this is my profit. And using color coding really helps. And of course, you're trying to maximize based on the exercise. And then your decision variables, as I mentioned in the announcement page, are 3 of them. And you select the ones in yellow. And then you start adding your constraints. This is the left-hand side. This is the right-hand side. So what we do is we just select the ones that have the same symbol.
Mm-hmm.
See, I can't select all the way through because I'm using less than or equal. And then I'm going to use this section as well and do add and do the next ones. These have the same symbols. Change this to greater than or equal. and then select the other section. And do add, and then I have the last one. This one is going to equal to this. And when I'm done, I click OK. For module 2, 3, and 4, for those we've been using Simplex LT or linear programming. You keep this one, you leave this check mark here. You don't take it out. And you just change this to Simplex LT. And then you click Solve. Obviously, we can't do it right now because you still have to figure out the rest of it. But this is exactly how this should be set up. Okay?
Okay.
I'm just going to close out of this. Once you click Solve, obviously you want to select the answer report. When you get to module 4, you'll be selecting the answer report and the sensitivity report. So hopefully this one helps you understand how to go about solving. But you're going to be using this a lot. So make sure you're familiar with how to set up quantities using the sum product function and using the ones and zeros. These two cancel out the other decision variables and leave you with just the one that you're interested in, that you want to be greater than or equal to 10,000 according to marketing department requirements. Same thing for restaurant. It will cancel out hotel and market and leave you with restaurant, and that is your constraint of interest, and that should be greater than or equal to 25,000. When you're talking about something that encompasses all the three, then you use 111 because you know they're talking about the processor's plant making all of these different blends and wants to stay less than or equal to 100,000 pounds per week.
Okay.
This required a little bit of calculation to figure out the cost, but this is how you go about going from beans at a certain percentages at a certain cost to figure out the blends that take these beans and mix them at a certain percentages. So you could use the sum product function in this case. For example, you could just say cost, and here you could have hotel, restaurant, and market. And for the cost here, you could use sum product. And that's how we do it in this fashion. We could do take this and then multiply by this. And I can use F4 because I want this section to be absolute. So the exact same thing we came up with, or kind of close. So in this case, let me make sure that the values, it should be correct. Is 20% times 0.60. And then if we add this 40% times 80 cents, and then 50% times 55 cents, 25% times 70 cents. See? Maybe earlier we didn't do it right, but see how it comes up to be the same?
Mm-hmm.
Either using the sum product or using the multiplication and the addition. So that is the way you go about figuring out the cost, and then once you figure out what that cost is, just plug it into your, we did come up with the same number. So the other ones, you plug them on under your cost section, then you figure out what your profit is based on selling price minus cost, selling price minus cost, and that will go here, and then the total profit basically will be your profit per pound for each of these blends. multiplied by the quantities that solver will come up with, and that will give you the total profit, which is set up in this exact formula.
Okay.
So what's your next question?
I've been so stuck on that honestly I didn't even have any more. I spent so much time on just this one problem.
Okay.
But that was so helpful. Thank you so much. I was missing, I don't know why, just the constraint part and the profit.
Okay. So with that being said, I think what I'm going to do, let me pause this very quick, and let me pull something that could help you with the next exercise.
What was that?
Let me pull up a spreadsheet that I can walk you through that could help you with Module 3.
Okay.
So for Module 3, bear with me 1 second. Okay. Let me share again my desktop, and then let's talk about Module 3, for example. And for the Module 3, okay, this is probably a good example for Module 3. Let me explain to you what will be covered in Module 3 in details. And what we're talking about for Module 3 is a different set of examples. We talked in Module 2 about allocation.
Mm-hmm.
We talked about covering, and we talked about blending. Okay. Now, in this module, we're going to talk about the network model. For the network model, there are 3 examples of network model. There's transportation model, and this could be used tremendously. Many companies that you might be working for or consulting with. So transportation could be one of the good examples to be used more frequently. There is also the assignment model, and there is the transshipment model. Okay? And when we try to set up the transportation model, you're following the same exact logic that you see here. And what you do is basically what's going to be given to you. It's going to be given in this kind of format. This is the from source, Minnesota, Pittsburgh, and Tucson. And you have 2 destinations, Atlanta, Boston, Chicago, Denver. And inside here, this is cost. This is the cost to ship 1 pound from Minnesota to Atlanta. This is the freight cost or the transportation cost. Okay?
Mm-hmm.
And this is the capacity. This is, you could consider this capacity or stock on hand. This is how much I have in this warehouse. Shipping, or this DC, shipping to this warehouse. I have 10,000 at this location, and I have 15,000 at this location, and 15,000 at this location. The requirements always go here. This is, you can also consider this as demand. This is what Atlanta would like to have, 8,000. Boston is calling for 10,000. Chicago is calling for 12,000, so on and so forth. In order to set this up in a transportation model, because this will be given to you, input variables or input information from the exercise or parameters. The best way to go about this is you could see this whole piece is then copied and pasted here. Mm-hmm. Except what we're going to have inside of this, matrix is that we're going to have quantities, not dollar values. Okay? So you could just make this a different color. What I would suggest to do is just copy up to here, copy that, paste it here. Take what's inside, delete it, make it a different color. Okay?
Okay.
And make it quantities. Because the quantities that you're going to figure out what's going to go from this warehouse to this distribution center. What's going to go from this warehouse to this distribution center, or vice versa. So what we're going to do here is write formulas that look exactly like this. Sum of these quantities. And drag that formula down. Here you do equal sum of these quantities, and you drag the formula over. You don't even need this box right here. Okay?
Mm-hmm.
Now, when you're dealing with transportation costs, you always have an objective function of minimizing transportation costs. So that's why we have total costs here. The formula that will go in this box is always going to be some product. Take this section by just highlighting over from this point all the way to the bottom corner to the right, and then do exactly like this, comma, and then highlight this section. And you can see how this is set up. And you hit enter. Okay?
Mm-hmm.
You see what I did? All what
Yes.
we're trying to do is figure out how this quantity will be distributed across these destinations, knowing that they are requiring this quantities to be received. Okay?
Mm-hmm.
In order to figure that one out, you could do it by, you have distribution planners that just sit there at the office and they keep thinking, okay, 10,000, I'm going to give it to the one that has the lowest freight cost per pound, so I'm going to send it to Chicago. Maybe for the next one, after I give Chicago 10,000, I need to give Chicago another 2,000, all right? So I'm going to take 2,000 from here, I'm going to send it to Chicago, and then whatever is left, I'm going to give it to the next, point of destination, which is that has the lowest freight cost, which is the 30 cents per pound. I'm going to give them the 10,000 they need. And I already gave Chicago 2,000, so I'm left with 3,000. I'm going to give 3,000 to Atlanta, right? And then Atlanta wants another 5,000. After I gave them 5,000 from Pittsburgh, I'm going to give them 5,000 from Tucson, and then whatever is left, I'm going to send it to Denver at this point. And I'm going to give them 9,000. All right? This is how you do it by just going through one item at a time. But Solver can do it for you very easily and very quickly, just as we did. You just copy everything. Imagine if you had multiple hubs multiple destinations. Think about 200 destinations. How are you going to figure that one out? It's going to be crazy. So in order for you to minimize on that time and do it the right way and be able to achieve the optimum solution, nothing would be better than that solution, is you set it up in this same fashion with the sum formulas across, and then the sum formulas working your way from here down to here, to ensure that what's sent is going to be below or equal to the stock on hand, and what's received is going to be greater than or equal to what's required, the demand. Just as we set up the demand previously with the allocation model, we're doing it exactly the same way, but it's just the format and the template is different. So once you have that, you go to Solver, and you'll see how everything is set up in Solver. You have the objective function, which is this, and you try to minimize, of course, we're talking total cost of transportation, and for your decision variables, it's going to be everything here, because these are the quantities the Solver would come up with. For this right here, has to be less than or greater than this quantity.
Greater than.
Greater than, yes. As you see here from the symbol. And then for, do we want to go beyond what we have on hand?
No. So listen.
We want to be less than or equal. And you can see how this is set up and with a simplex LP. What I'm going to do is I'm just going to do Control Alt screen. I'm just going to paste it right here.
Okay.
That's it. This is how you set up every transportation model. No variation. Absolutely no variation. So whenever you go across any transportation model, you set it up exactly the same way. These exercises are available to you in the module resources. Okay?
All right.
So you know how to get to those, right?
Yeah.
Okay. So what I'm going to do is I'm going to run this. Okay. When you see this, just make sure, when you see this, just make sure you just get, okay. Home. Oops. Let me take home. Let me take home. Okay. See that?
Mm-hmm.
This is what Solver came up with, and this is the optimum solution.
Okay.
Now the exercise is going to ask you to draw a diagram. For this, it shouldn't be an issue. The webinar does explain how to in detail, but I'm just going to show you quickly that you can do it in this fashion. For example, you're going to have all your from sources on the left, okay? So you're going to have 3 nodes or 3 circles. And obviously on the right-hand side, how many circles you're going to have?
The 4.
4, exactly. And this will represent what? Minnesota. So for Minnesota, you're going to say, okay, what's going from Minnesota and where is it going to? Is it going to, once you write down the names and everything, so Atlanta and so on and so forth, Boston, Chicago, and Denver. So this is, so I just do Control C, Control V, and now I have all my circles. I can put here, that's Atlanta, and this is Boston, and this is Chicago, and this is Denver. So when I do this, I just insert shapes, and I say, okay, what's coming in here is this quantity 10,000. I write 10,000 up here. Okay?
Okay.
Right above that. And I just do it in this fashion. 10,000. What's going out, you know how to keep this ready? So, it's going directly to who? To Chicago, right?
Mhm.
From Minnesota we have, and how much is going there?
10,000.
10,000, exactly. So we write here 10,000. And how much is being received is, so you can do this in Excel, you can do it in Visio, you can do whatever. And then you have 10,000 coming out.
Okay.
And then we can put 10,000 here, or received. Okay?
Mhm.
If you do Pittsburgh, you're going to have multiple arrows coming out of Pittsburgh. One is going to Atlanta, and the other one is going where?
Boston.
Boston. And then, obviously, you write down 15,000 in this section. You write down how much was sent to Atlanta, right here. That's 5,000. How much was sent to Boston. And then you continue working your way through with Tucson and understand how much was received finally, how many arrows came to Atlanta. There was the 5,000 one, and there was the arrow coming from Tucson of 3,000. So what you received, the total is 8,000, and that matches your demand quantity. Does that make sense?
Yes.
Okay. That's it. That's as simple as you can see it. They're all the same. All the transportation models are set up the same. No variation. The only thing that's going to vary are these quantities, and these quantities. And of course, the names, labels, the number of from sources, and the number of to destinations. Okay?
Okay.
All right. So for the assignment model, it's pretty much exactly like the transportation model, except for the assignment model, there is a 1-to-1 relationship. Okay? And what we're saying here is these are plants, these are different plants, and these are different models, different car models. What we're trying to figure out is whose plant going to make what type of car.
Okay.
And they're only going to make one and only one car. That's it. They're not. So this plant A, it either has to make compact or coupe or sedan or SUV or truck or van. They can't make any other ones. B, if A is going to make sedan, B cannot make sedan. It has to make any of the other ones but not sedan because A already took that one. Okay? That is when we use assignment model, is when we have 1-to-1 relationship. So for you to set this up, this is the cost. Always what's in the grid is cost. You've seen it here. This is the freight cost. This is the cost to make this type of car at this plant. This is 80 million. Okay, this is in millions. So what you're trying to figure out is how to set this up to where you figure out the minimum cost possible to make these cars at these different locations. If you do it by just scanning through this, it's going to take you forever and you might not achieve the optimal cost possible. But to do it through Solver, what you do is the exact same thing. You copy everything. And there is an exercise in Module 3 exactly the same way, except it talks about programmers and it talks about tasks. There will be one programmer assigned to one task. So what you do is you copy everything, you delete what's in here, make it a different color, so you can figure out that this is my decision variables, make sure that they are They are numbers, not dollars. And here you set up your formulas. Same thing. Sum. See that?
Yeah.
Sum. Here, it will be what?
Some.
Sum, exactly, of this from top down. And you could write sum and just drag this across. Once you set it up this way, you're pretty much done with your decision variables. You come here to your objective function. Your objective function is going to be some product of what?
The two tables.
Exactly. That's exactly right. Now, for the assignment model, there's one thing different from assignment model compared to transportation model. Is you come here, and you can see how constraints are set up. The top section is set up exactly the same way. But this section here, what we're saying is this should be greater than or equal to 1. And this section should be less than or equal to 1.
Okay.
That's it. The rest of it is the exact same way as the transportation model. I'm going to do the print screen to this before I click solve and do OK. The solver found a solution. All constraints and optionality conditions that are satisfied. Make sure you click the answer report and so you generate the answer report. And you put this here. This is exactly how you set it up. All the assignment models are set up the same. I'm going to make it in this fashion and maybe format cells and make it number. Okay. All right. This is better. And this is my minimum total cost possible. You don't need to provide me the print screen. I just show you this so you know how to. So this is how transportation model is set up. This is how assignment model is set up.
Okay.
Okay? We'll do the transshipment and we'll call it done. So we'll try to finish this one in the next 5 minutes. Would that sound good?
Yes.
Okay. So for this one to set up the diagram, it will be pretty much simple. You will just have a circle for A, right?
Mm-hmm.
And that arrow is going to go to number. The arrow is going to go to which one of these? From A to?
3.
Very good. And for B, we're going to have an arrow going to where?
2.
2, exactly. So you're going to have A, B, C, D, E, F. And you're going to have on the right-hand side, you're going to have 1, 2, 3, 4, 5, 6. And then you're going to have arrows. How many arrows coming from one circle to the other circle?
Just 1.
Only 1, exactly. Because we have a 1-to-1 relationship, remember? So yeah, we have a 1-to-1 relationship. And this is how we set it up in Solver. This is assignment. That's transportation. For the transshipment model, and remember, these are all available to you in the modular resource. That should help you get set up on these. For the transshipment model, all we're doing is taking, remember the first stage of transportation model, and we added another stage for the transportation model because we have from, to, and from that to another destination. That's what we call a transshipment, right? So the way you set it up is you set it up in the same fashion. From, to, just like you do in the transportation model. And know you have stock on hand. And you come here and you set up your decision variables. And you do the sum, the sum, the sum, the sum, and the sum. Okay? You don't write the requirement like we did earlier, the demand requirement down here. You write them at the final destination, which is your 2 final destination. You see what happened here? We had some, and it changed to 2 here. Reason why? Because we want to keep this the same. See distribution 1, distribution 2. And then once it gets to distribution 1, distribution 2, from this distribution 1 to warehouse number 1. From distribution 2 to warehouse number 2. See that? And the reason why we do this, because if we add another distribution, we can just insert another column and just call it D3, and it will be easier to set up.
Okay.
That is why it's a good practice to set it up in this fashion. So your goal is what you do with any transshipment model. You copy this box and you paste it right here. Take what's inside, do the exact same thing, do the sum formula, and work your way through. Drag this formula down. Same thing, import sum. Drag this formula down, and then drag it across, and make sure you have a box here that takes some product of this times this. That's stage number 1. Stage number 2, I'm going to do the exact same thing. Copy this, paste it here. Take what's inside, and make sure the equal sum of this, and work my way through. And then this one is sum of what's in here. Same thing. See? Then I do the sum product of what's in here, multiplied by what's in here. Oops. Makes sense? I'll make sure that these are numbers. I don't need those many decimals, but that's not what we're worried about. For the cost, it would be just the cost of this stage plus the cost of this stage. See? Equal this plus this. And that pretty much completes our setup of the model. So anytime you're talking from plants to distributions, and from those distributions to the warehouses, you set it up in this fashion.
Gotcha.
And as you could see, we just copied the information, the box. You don't have to copy anything. You could just create your own box. Make this as just numbers because you try to figure out the quantity. And then put your sums here, sum here, and then do the sum product. Do the same thing here. Make a box that is the same size as this box right here. This sum. You don't even have to write it up above. If you want, you can make it down here and stay equivalently. And then do the sum product of this multiplied by this. And then add the 2 stages together to figure out the objective function. Okay? Now when you set it up in Solver, what you do is you say, I want to minimize this one, C20. Minimize, make sure that's selected. But look at this. By changing what decision variables? Well, you're changing this decision variable in this matrix, and you put a comma. And then you select the other one. Okay? All right? And then this is what you have. You have to make sure that what's received is greater than or equal to what's being required. Right? That's your demand requirement. Always greater than or equal. Is it okay? Yeah, we already got that one. this one here, this is what's been received at the distribution centers, right? It has to equal what left the distribution centers. That is the one thing that is different about transshipments. And of course, the last one is what's been sent has to be less than or equal what we have on hand. So what we're saying is this one and this one is pretty much the same as the transportation model. We've seen that before. The only thing that we added is what comes into the distribution centers leaves the distribution centers. Okay? I'm going to do control point screen before I do solve. There you go. These are the quantities that we need. So this is pretty much your schedule. You tell everyone, since you'll be if you are the distribution planner or if you're providing information distribution planner, you tell them, I want to ship from plant 1, I want to ship 1,100 to distribution 1 and 1,300 distribution 2. From plant 2, I would like to ship 2,750, all of it to distribution 1. And then 1950, I wanted to go directly to distribution 2. That would minimize my cost for stage 1. And once they arrive at these distributions, this is how I want that to be distributed to the warehouses going to the next stage. I want to send 1,250 from DC1 to warehouse number 1, and nothing from DC number 2 to warehouse number 1. So DC for distribution center number 1 will distribute to 3 warehouses, and the other one will distribute to the other last 2 as being provided from the model. Does that sound good? And that is how it's set up. And if you set it up in the diagram or the network flow diagram, you will have a set of circles. These first section here represent what? You have 3 sections. What does this represent?
The plants.
Plants, exactly. And what does this represent?
The distribution center.
Exactly. And what does this represent?
The warehouses.
Exactly. Perfect. And how many is going from plant 1 to distribution number 1?
1,100.
1,100. So when you draw your arrow to this B1, see that, is that making things simple? Okay, so when you draw the arrow just right above it, 1,100, and then from P1 to P2, how many is going up to B2?
1,300.
1,300, exactly. And then from D1 to W1, how many is going?
1,250.
Perfect. That's it. So, and for the constraints, what we're trying to make sure the solver provides us with is that we got to make sure that what we send from P1 and P2 and P3, whatever is sent, does not exceed what we have in capacity. That's number 1. And whatever is received at these locations should be greater than or equal to the requirement that they're asking for. And the third one is whatever comes to these distribution centers, we assume that there is no scrap, no issues, and they have to be equal to what's sent to these warehouses. Otherwise, the optionality is not going to work perfect. So we're assuming that, hey, distribution 1 receives 5,000, that is exactly what's going to leave distribution 1. Assuming that everything is perfect world. So this is how it's set up. We'll just do a print screen. I'm just going to put it right here for you. That's it. That's module 3. So I expect that you're now going to nail that module 3 and module 2. And the midterm is no different. I think you should do a great job with the midterm now that you understand this. So please get caught up. Make sure you get this turned in by latest Monday. And you know, if you have any questions, let me know. I think the one particular problem that you might face would be exercise. Yeah, the module 3 problem set. There is a exercise 3.8. That is college expenses. For the college expenses, make sure you go to the link I provided in the announcement page.
Okay.
Chapter 3 tab. There is a tab called Invest.
Okay.
Go to that tab. It will be closely similar to how this is set up. Just open that tab, copy it to your Excel spreadsheet, and then start changing the data, and your model should work perfectly.
All
and
right.
for the other ones, assignment and transportation, I think you're pretty good with that one. You shouldn't have any problem going forward. I will record. It's recording, so I will try to post this for you sometimes today. I'll try to shoot for today and have it for you on YouTube so you can review if you need to. And if you have any questions, email me, okay?
All right. Thank you so much.
You are very welcome. And you also need to do problem sets for Module 5. So get caught up, change that grade to at least a B, okay?
All right.
All right. Good luck.
Thank you.
All right. Bye-bye.
Bye.